everybody, happy Thursday. Today our shout outs are going to go to, first a special shout out to Owen and Lucas Isaac, because they've done all of Lily's math forms lately. I haven't seen her name on any of the forms. We'll give a shout out to Victoria because she saved the week by helping us organize something. And then a shout out to my hairdressers, Jamila and Rachel. I miss you sitting at the back table braiding everybody's hair and taking all my elastics. Today's goal is for you to be able to decide if an equation is linear from a graph, an equation, or a table. This is going to be one of the easier lessons that we've done the whole time we've been in quarantine. So let's get started. Let's get started. All right. So you've used equations since you've been in first grade. An equation is anything that has an equal sign. 1 plus 1 equals 2 is an equation. Anything that has an equal sign and something on either side is an equation. But there are some equations that think they're better than all the other equations. And our next little mini unit deals with the 3 types of equations that think they're better than all the others. The first equation that thinks it's better than all the others is what we call linear equations. Now, you've dealt with linear equations. That's all we've dealt with this year, really. A linear equation is an equation that if you graphed it, you would get a straight line. They don't like circles, they don't like curves. Only straight lines get to be called linear equations. And so today, we're going to show you how to decide from a graph if an equation is a linear equation, from an equation, and then from a table. So the easiest thing to do is to decide from a graph whether or not you have a linear equation. This is simple. You're just looking for a line. If something curves, it's not linear, so this would not be a linear equation. There's an equation that graphs this graph, but it's not a linear equation. This one does make a line, so this would be a linear equation. The next one is not a linear equation. There is an equation that gives you this graph, but it's not linear. And then our last example is also linear, because we get a line. So these 2 graphs represent linear equations. Very easy to tell if a graph is linear. So now on to an equation. How do you tell just by looking at an equation that it's going to make a line? So for the next section, scroll up. In order for an equation to make a line when you graph it, you have to have no powers with variables. You can't have any division with variables. You can't have any variables being multiplied together, because that would cause a graph to curve. So for this first equation, I know right away that if you graph this, if you plot points for x and figure out what y is to make this true, it will not make a line because it has a power with the variable. This next one would make a line. It has x's and it has y's. You could rewrite this to y equals mx plus b, and you know y equals mx plus b makes a line. So this would be linear. Our next one is a vux, and vux equations are lines. For the last one in that row, that's a y equals mx plus b. That would give you a line. For this next example, we have an x and a y being multiplied together. When you multiply your variables together, you get curves. You do not get a line, so this will not be a linear equation. Our next example has a power with the x. That makes it not a line. Our next example is a HOI. It's a y equals equation. That would give you a horizontal line, so that works. In our last example, y equals 2 divided by x. We can't have divided by x because to get rid of divided by x, you would have to multiply by x. And you're not allowed to have variables being multiplied together. This would not give you a line. So these 4 represent linear equations. You're looking for y equals mx plus b, a vux, or a HOI. or a standard form equation. You can't have exponents with your variables, and you can't have variables being multiplied together. And then the last area that you need to be able to recognize linear or not linear from is from a table of points. Now you could plot this table of points and see if it makes a line, but for the most part we're going to be looking at the slope. In order for something to be a line, it has to have the same slope between all the points. And because we have a table, slope is y minus y over x minus x. Because we have a table, I'm going to use the arrow method to get my slopes. To get from 3 to 8, it would be plus 5. To get from 0 to 1, it's plus 1. So here my slope is 5 over 1, which is 5. From these 2 points, to get from 8 to 13, it's plus 5. To get from 1 to 2, it's plus 1. That's also a slope of 5. To get from 13 to 18, that's plus 5. From 2 to 3, that's plus 1. So that's also a slope of 5. And our last points, that's also plus 5, plus 1. So the slope remains 5, the whole entire table. So this would be a line if you graphed it. So this is linear. For our next example, to get from 7 to 11, I'm always starting with my y's, right? I would have to add 4. To get from 1 to 3, I would add 2. So my slope would be 4 over 2, which would be 2. From 11 to 15, that's also plus 4. From 3 to 5, that's plus 2. So that's also a slope of 2. And then my last one, this looks like it might not work. To get from 15 to 45, that's plus 30. To get from 5 to 20, that's plus 15. 30 over 15 is also 2. So this would create a line. If you plotted all those points, they'd all be on the same line. So this is linear. And for our last example today, I'm going to start with y. My table's written differently, but I'm going to start with my y's. To get from 12 to 6, I would have to subtract 6. To get from 1 to 2, I'm adding 1. So my slope would be negative 6 over 1, or negative 6. To get from 6 to 4, I'd have to subtract 2. To get from 2 to 3, I'd have to add 1. Now my slope is only negative 2, so they don't have the same slope going from points to points. So this would not make a line, so this is not linear. So the linear equations would not include this table. So now you can go to Flipgrid and practice some more, but there is a Kahoot for you today to try very quickly, see if you can spot linear versus nonlinear from a table, a graph, and some equations. So try the Kahoot.